Hi guys, Mr. Bennett here. The final example we're going to do for this is method 3, where we've got a function which is a fraction. Alright, so let's do an example 1. Let's say we had f of x equals 1 over 2x take 4. Alright, so that's our function. Alright, so essentially what we do is we put it straight into the formula. So f dashed of x equals the limit as h goes to 0. So now all we're doing, our f of x plus h is going to be 1 over 2x plus h take 4. I need to get rid of that bracket, don't need that there. Slow thing. So we've got our x plus h in there, and then we're going to take away our f of x, which is 1 over 2x take 4, and then that's all over h. Alright, so now because we've got fractions, then what we need to do is we need to bring these things over the lowest common denominator. So we cross multiply. It's a pretty simple process. I know you guys can all do that. Again, we're going to get a fairly ugly looking bottom line, but I don't really care, alright? Because we're going to simplify it. It simplifies itself at the end anyway. So down the bottom line, you're going to have 2x plus h take 4, and then you're going to have 2x take 4. So don't even think about it. What have you got there? Now, if we're going to cross multiply, that's going to go to that side over here, and then that's going to go to that side over there. So then what you're going to be left with, you're going to be left with 2x take 4 times by 1, which is going to be that, and then you're going to have take 2 lots of x plus h take 4. Again, make sure you put a bracket around it. Alright, and then when we go through this next bit, we simply go through, we expand the top line, and then we collect like terms. Now we don't do anything to the bottom line again. We keep the bottom line the same because it will sort itself out once we've got everything sort of done. Take 4, and then 2x take 4, and again they all work out exactly the same, so don't panic. Alright, so 2x take 4. Alright, now we're going to expand this out at the same time we're timesing that through, so that's going to be 2 times by x, and that's going to be minus, that's minus 2x. That's going to be 2 times by h, so minus, so that's minus 2h. And then that's going to be minus 4, which becomes plus 4. Now again, as I've been harping, we know we've made a mistake if these terms that don't have a h in it don't cancel. So if I didn't have my bracket there, that would be probably negative 4, and that wouldn't cancel out with a plus 4 there. Right, now just to save time, okay, we can cancel that h, because there's only one term there with that h there, and so therefore that's leaving me with the limit as h goes to 0 of negative 2 all over 2x plus h take 4, 2x take 4. So when we take the limit through, so therefore f dashed of x is simply going to be, that's going to cancel out, will be exactly the same as that term there. So it's going to be equal to minus 2 all over 2x take 4. Now there's 2 of those, so what I'll just make that square. That's done. Okay, so we've done that one there. Let's do another example which is slightly harder. Doesn't have to be much harder, but let's do one which is a little bit harder. Let's do f of x equals, let's put a 4 up there and make that 2x, well, let's make it 2x cubed plus 1. Alright, so if we're going to do this one, so we do exactly the same process. F dash of x equals the limit, so h goes to 0, of our f of x plus h. So where I see my f of x plus x, I put an x plus h, so that's 2x plus h cubed plus 1. Take away f of x, which is 4 all over 2x cubed plus 1, and then that's all over h. Now, if we go back to our cheat sheet, which I've got for you, it's the type 3 problem. Okay, so we bring over the lowest common denominator, we expand, and then we cancel. And there's a couple of examples here for you to do. So let's just keep going with this one here. Right, so if we bring it over the lowest common denominator, again, we don't think about it, we just, whatever we've got there, we bring it over. So that's going to be simply h bracket 2x plus h cubed plus 1. Definitely don't expand this. And then that's going to be times by 2x cubed plus 1. Now, top line, again, we cross multiply. So that's going to get timesed up there, and that will get timesed up there. So then that will leave us with 4 lots of 2x cubed plus 1. Take 4 lots of 2x plus h cubed. Oh, pen, it's not working properly. Plus 1. Okay, now this is going to be the tricky one where you might use your Pascal's triangle. I know x plus cubed is going to be equal to x cubed plus 3x squared h plus 3x h squared plus h cubed. Alright, so if I keep that back in the back of my mind, when I do this, I can make life a little bit easy for myself. Alright, so that's equal to the limit as h goes to 0. Now, expand that through, that's going to become 8x cubed, right, plus 4. Okay, you've got to put it through both terms. Now, I could combine that to go 4 times 2. That's going to give me 8, isn't it? So 8 times by, so that's going to be take 8x cubed. Now I've got to times that by 3, don't I? So 8, so it's going to give me take 24x squared h. Take 24x h squared. And then that's going to give me take 8h cubed. And then 4 times by, negative 4 times by 1 is going to give me negative 4. Right, so not that nice, but again, we're only expanding the top line. And then we're going to look to see if we can cancel things that are the same. On the top line, any term that doesn't have a h in it should do what? It should cancel, shouldn't it? If we don't cancel there, we know we've made a mistake somewhere. So, you know, in terms of the question, if you have time, you can then go back and work out what's gone wrong. Alright, so let's cancel 8x cubed with minus 8x cubed. Right, plus 4 with negative 4. Okay, every other term now has h in it. So therefore, what we can do is, it's okay to do this, cancel that with that, cancel that with that, cancel that with that, and leave a 2. Alright, so now that's going to leave me with the limit as h goes to 0 of minus 24 x squared, take 24 x h, take 8h squared, and then that's all over 2 lots of x plus h cubed plus 1, times by 2x cubed plus 1. Alright, takes a bit of time, but yeah, you'll get a lot quicker at this as you work through it. So now I can take the limit as h. So any term with a h in it, the h is going to go. So that's all going to go because it's going to be 0, and that's going to go because that's 0. And that's going to leave me with, therefore, f dashed of x is going to be equal to minus 24x squared all over 2x cubed plus 1, and that will be squared. And that's it, done, finished. And we will show you in the next section when we start doing proper derivations that, you know, this is a lot quicker way of doing this. Remember, this stuff is a proof, all right? So if you keep that in mind, we're proving that we can find the slope of the tangent at any point. And obviously, if we wanted to put our value of x in here, we could work that out, couldn't we? So if we had f of x equals 1, we could say that's equal to minus 24 times by 1 squared all over 2 times by 1 cubed plus 1, and that would be squared. So 2 times by 1 cubed is 2, plus 1 is 3. 3 squared is 9. And then that would be minus 24. So that would be the slope of the tangent when x is equal to 1 would be equal to minus 24 on 9. There you go. Alright, now the next section I'll need to show you how to do the first principles a slightly different way. That can be a little bit easier on some occasions. Alright, so we'll go through that in the next video. Alright, see you for now.